Welcome to Get Your FRQ On. This question is from the 2003 exam. It's question 3, and it is calculator active. In the question stem, we are provided with information, a graph, and a table about the rate of fuel consumption for an airplane flight. In part A, we are asked to approximate r prime of 45 to show our computations that lead to the answer and provide the specific units. We are also instructed to use the data from the table, not the graph, in order to compute this. So based on the table provided, the approximate value of r prime of 45 can be found by using a difference quotient. R of 50 minus r of 40 over 50 minus 40. Taking the values from the table, r of 50 is 55, r of 40 is 40, and 50 minus 40 is 10. So r prime of 45 is approximately 15 over 10, which is 1.5. Now with the correct units, r prime of 45 would be 1.5 gallons per minute per minute. In part B, we are asked to find r double prime of 45 and explain our reasoning. So this question requires very little computation and quite a bit of understanding about calculus concepts. We're given that r of t is twice differentiable. Okay, great. That implies that both r of t and r prime of t are continuous. We are also given that the rate of fuel consumption is greatest when t is equal to 45. This implies that the function r prime of t has a maximum value at t equals 45. Well, if r prime of t has a maximum value at t equals 45, then, since r of t is twice differentiable, we know that r prime of t, its derivative, at 45 should be 0. Well, the derivative of r prime of t at 45 is r double prime of t at 45. So that would have to be 0. Not a lot of actual computation here, just understanding calculus concepts. In part C, we are asked to approximate the integral from 0 to 90 of r of t dt with 5 left endpoint rectangles, and then to determine if this is an overestimate or an underestimate. Using the data from the table and 5 left-hand rectangles, the integral from 0 to 90 of r of t dt is 30 times 20 plus 10 times 30 plus 10 times 40 plus 20 times 55 plus 20 times 65. Now, even though this is a calculator active question, you can use your calculator to come up with this integral, but you have to be clear about what you are asking your calculator to do. So it would always be a best practice here to actually write this out by hand. This integral is equal to these products, the sum of these products. And then once you have that written down, then you can use your calculator to actually come up with the integral. So if we add up all the parts on the right, we get that the integral from 0 to 90 of r of t dt is 3,700. Right, we're also given in the question stem that r of t is strictly increasing. So if it's increasing and we used left endpoint rectangles, our left endpoint rectangles should always be an underestimate. So this integral value, 3,700, is an underestimate for the actual value of the integral from 0 to 90 of r of t dt. So we can conclude that the integral from 0 to 90 of r of t dt is actually greater than 3,700. In part D, we are asked to explain the meaning of the integral from 0 to b of r of t dt and 1 over b times the integral of 0 to b r of t dt, and to provide units. Again, this is a problem that doesn't really require a whole lot of computation. In fact, not really any at all, just some understanding of calculus concepts. The integral from 0 to b of r of t dt is just the total amount of change in that function from 0 to b. So the integral from 0 to b of r of t dt represents the total gallons of fuel consumed in the first b minutes of flight. The other integral, the value of 1 over b times the integral of 0 to b of r of t dt, That is an average value integral, so that integral represents the average value of the function r of t in gallons per minute over the first b minutes.